Hi everyone, this is Steve Christensen. I hope you're having a wonderful day. Let's talk today about distribution system facilities. What's the purpose of the distribution system? It's to deliver adequate quantities of water at sufficient pressures at all times under continually changing conditions while protecting the water quality. A typical distribution system. Continuous positive pressure should always be maintained to prevent contamination. This gets into those hydraulics. All of a sudden you get back siphonage or anything else that could suck in contamination. Water flowing in a pipe with loose pressure due to pipe friction. Now, you think about it, and concrete pipe, it's kind of porous like sandpaper, and there's actually friction. So you actually lose efficiency in the pumping capacities. Large variations of pressures are not desirable. You want to go ahead and maintain kind of a constant pressure. Ideally at the customer's tap, it's going to be going into the house 40 to 60 pounds. Mains normally are running 80 to 120 pounds. It really varies. Some of the new systems now, however, are all the way up to 200 psi. That's a lot of pressure. And again, obviously you have to put pressure reducing valves in then at each curb stop to go ahead and make sure that the pressure comes down and you blow the pipes right out of the wall of the house. A typical distribution consists of fire hydrants, pipes, valves, storage tanks, pumps, and other appurtenances. An appurtenant is like a meter or an air vent or any of those kind of things. A hydraulic grade line is above the hydraulic grade line is negative pressure. In other words, it's going to suck it down with it. It's again those hydraulics. It's always sloped downward in the direction of the flow, and it's a straight line. You can see the cutaway on the upper right, and certainly you see your hydraulic grade line. Point A to point B is what we're talking about. Water pipe. Significant installation features for new water pipe. Available sizes, the ease of tapping, joining the pipe together, the weight, soil conditions, so on and so forth. Many things go into it. Economic capabilities, what's in your bid? How much money do you have to spend? So pipes are water pipes used in distribution systems. We have ductile iron pipe, which is heavy and expensive. The thing with ductile iron pipe is there's absolutely no give in it. It's got to be a complete perfect seat. We have PVC water pipe, which is the most common by far. PVC is polyvinyl chloride. It has permeation problems. So in other words, it's made out of oil. Plastics are made out of oil. So if all of a sudden you're going through a contaminated site where there used to be a gas station or underground storage tanks that have leaked, that kind of thing, it can actually eat into the plastic. Threading is absolutely not recommended. This is all bell and spigot, and we'll get into that in just a second. Concrete pipe. Concrete pipe can go huge. You also have concrete lined steel pipe. These are precast pieces. They're huge. They come in on the back of trucks. It takes a crane to set them. Very complex. Steel. It's more corrosive than iron pipe. We have galvanized steel pipe, cement lined steel pipe, liquid epoxy steel pipe. Steel pipe is the not ideal by any means. If any of those surfaces that are protective surfaces get pitted, it's an open ticket for corrosion and eventually leaks. Asbestos cement, AC. AC is not in use anymore, but I shouldn't say that. They don't sell it anymore because of the asbestos. It actually works very well as water pipe, but what happens is when it cuts, it creates a dust. And it's that dust that's the asbestos that's so dangerous. Asbestos can live in your lungs for 50 years and all of a sudden kick up and give you cancer. So it's no longer being used and slowly being replaced. Oftentimes these small systems and even some of the larger systems have multiple types of pipe in their systems. So factors to consider when selecting a pipe, the type of pipe for a specific installation. The corrosive conditions of the soil and the water. pH, the alkalinity. The cost of the pipe. The installation ease. Internal and external pressures. Caring for your water pipes. Lines and coated pipe must be handled carefully to avoid damaging the protective surface. It used to be very common that they would use steel pipe that was basically coated with tar on the outside. Those things are famous if there's a rock or any kind of pebble next to it because of the vibrations of the water going through. Eventually it's going to wear right through that tar, and then pretty soon you're going to have a leak. Water hammer. Water hammer is you probably have heard in a house when you turn on and off a faucet, it bangs in the walls. That's water hammer. That's the pressures of coming on and off. And, bottom line, those pipes are not secured correctly, and they certainly need to be. And it's the same thing on a bigger scale in water systems. And in water systems, we're more concerned about the turning pumps on and off. So when we're installing the pipe, we're looking at a bunch of things. Obviously, safe working conditions. You always want to have a 2-to-1 slope or shoring involved. You see on the left-hand side, that's PVC. You can see the black gasket inside of there. You always want to have a level surface that is being laid on. And also where the bell is, which is the flared out section, it's always got to be 100% supported. T or branching distribution systems should be avoided. Dead-end lines, okay? You get not very much movement in that, and you say you have a cul-de-sac and there's only a couple people down there and they come and go. Bottom line, that water can get stale and it doesn't stay fresh. So it creates stale water and taste and odor problems. Ideally, you want to have a looped system. So you want to make sure the entire pipe barrel is supported, like I mentioned. You want to always disinfect before placing it into service. Contamination is always an issue. Anytime you're working on a pipeline, it's got to be disinfected. Changing pipe, changing a valve, so on and so forth, small to large. Trenches must be deep enough to protect the main line from freezing, river erosion, and surface traffic. And again, these lines normally, when you're talking about these size lines, are going to be inspected. And so certainly if it's going in a roadway, it's going to have a different spec than if it's off on a right-of-way where there's no traffic. But certainly river erosion and any kind of subterranean movement with dirt and water and all that kind of thing is a huge concern. Gate valve location. Gate valves are an operator's best friend. The reason why is because you're going to be able to isolate little specific sections. And by isolating those sections, if you have to work on that section, you're not shutting the whole system down. Excavations for water pipe. Like I mentioned, you would never want to throw concrete or asphalt back in the hole. You've seen these big ditchers that they use in installing pipeline, the ones with a really big wheel. They're like, 14, 16-foot wheels with diamond blades that go right down the street. Those actually have a situation that's designed into it where when it pulls out the dirt, it puts it through a screen and removes all the rock and debris. And then that clean material, which is piled along the side of the ditch then in a nice, neat manner, getting ready for backfill, is called shading. So excavation must be inspected on a daily basis by a competent person. What's a competent person? Well, technically it's an OSHA certification, although there's a lot of job sites that don't have a specific competent person. And when there's not a certified competent person, who's the competent person? Somebody's got to be in charge. A boss. You can't have 5 guys and gals go out there working on a project with nobody who's creating leadership. So again, that competent person is looking out for the safety, and they're looking for atmospheric conditions, hazardous waste, potential cave-ins, protective system failures. It's a safety issue. Trenching and excavation safety. Shielding. Shielding is a large steel box that is opened on the ends, top and bottom, and is lowered into the trench. And again, worker safety, cave-ins. Before OSHA came along when I was young, it seemed like every night on the news we'd hear about construction accidents and cave-ins. But it's really changed over the years. Accidents still happen, but nothing nearly as much as it used to be. There's a lot of inspection, and there's a lot of responsibility if there is an accident. The federal government and OSHA and Cal OSHA, they hand out some pretty darn heavy fines if somebody's out of compliance and there's been an accident. Shoring. Okay, so shoring is basically the same as shielding, except it's put together in pieces. And you always want to start at the top and work down because of cave-in situations. So sloping excavation, you can see on the bottom picture the slope. Well, actually, the one on the left is legal. The one on the right is not, because see how it comes down and then it drops off real sharp? It needs to be a 2-to-1 slope. And again, this is going to depend on your soil conditions. If you're in really bad soil conditions, sandy, that kind of thing, you're in much more susceptible area for cave-ins. So the lack of shoring or shoring failure is a major cause of underground construction death. Shore trenches when hazardous ground movement is expected. Okay, we live in California, the land of the shake. And again, so you can guarantee there's a lot of shoring that goes on. Selection of shoring is dependent on the soil conditions. Sloping may be used if it's more economical and the job can be done safely. When testing for leakage and pressure, avoid high velocities to prevent movement and leaks. One of the things you always want to do is when you're installing a water pipe, is go ahead and get it to the point that it's pressurized before you backfill it. Cover it all with dirt. It's a lot. You don't want to go back and have to start digging it up. Believe me. It's a lot of work. So here's a mechanical joint. Mechanical joints are bolt-together joints with flanges and rubber gaskets. They're easy to install and they're flexible. And what I mean by flexible is a mechanical joint, actually you can bend it a couple degrees because of the mechanical nature of it, where a lot of pipe you cannot bend whatsoever. And oftentimes with soil conditions and pipeline excavation, you're having to make, it's not perfectly straight lines. Actually, and that's one of the advantages of the ditching machines and excavation machines are those big wheels, because they do very perfectly straight lines. Bell and spigot, PVC. Okay, what we're looking at here is a couple things to point out. We've got a very special lubricant that we use. Now you can see right through here, there's a black rubber gasket in there, and that's called the rubber. So you basically go ahead and lube up that gasket. It sits in a recessed ring in there. And then you also see the line on the pipe here. Well, when you slide it in, it actually slides in, and that point right there seats right at the bell. So that's one of those fail-safe things. This size pipe you can actually put together fairly easily with a pry bar and a 2x4 on the end of the bell. And you line it up straight, and you push it together, and it's a very positive seating feeling when it hits in. And again, it goes in roughly, depending on the size of the pipe, but roughly about 6 inches on this size. Thrust blocks. Well, we were talking about water hammer. Thrust blocks is the concrete that reinforces pipelines. And you basically, anytime there's a change in the direction of the pipe, a sudden increase in velocity or decrease or sudden stoppage of flow, that needs to get reinforced with concrete. And again, new pipeline construction is always designed by civil engineers. However, when you're in the field, sometimes you might be doing a repair and you might have to go ahead and just go ahead and put in your own thrust block. So again, anywhere the water's turning or there's changes in the direction of velocity, flow stoppages. So what this is showing is basically where you put your concrete, and reinforcing your different joints. And again, you don't want to totally enclose a valve. That would be actually fatal, because you've got to be able to go ahead and basically be able to access this valve with a key. So it's anywhere it turns, and what you're showing here is a big block of cement, and you've got a band that goes around to support it. And again, there are specific formulas, but they're engineering formulas for thrust blocks, and it's a design thing that gets in with the civil engineers, factoring on pipe size, pipe pressure, soil conditions, so on and so forth. Okay, so again, it depends on the size of the pipeline, the character of the soil, the type of the fitting needing the protection, and the water pressures. You can see this one. You've got a T coming in, you got a gate valve there, and there's your T. It goes each way. You can see the fitting here on each side, so that's how I know it's a T, even though you can't see the pipe over here. But you can see the way they designed this thrust block is you got water coming here that's dead ending. But they also did it to where they're not totally encasing the pipe joints. It's very hard to go ahead and repair these things, and if you put too much concrete in, it's a real pain in the rear to start chiseling it out if you have to go ahead and do a repair. Air in the water pipes. Air in the water in the distribution system causes air pockets, which reduces or stop flow. If anybody's ever worked on a car and changed a radiator, you have to burp a radiator to get the air out of it, otherwise it becomes airlocked. Well, air certainly is going to go and seek the highest point in distribution systems. And at those highest points, they will have engineered in air valves. And air valves are basically a ball valve that floats, and when the air goes up, it pushes against it and seats it. When there's air in it, the ball goes down, allowing the air to escape. Air can get in the system from air that exits in the water, leaky joints, packing glands, and pumps. Broken water mains. Okay, you look at the top right one. That one, who knows, but it could have been hit by a backhoe during some kind of excavation, storm event, numerous things, but that's a pretty healthy break right there. You obviously see the fire truck. You see the guys in the geyser. I don't know if they've got a key there and they're trying to shut that thing off, but it can be a frustrating situation, especially if they're old valves that haven't been exercised. Exercising a valve is basically exactly what it says, working it up and down every so often to make sure it stays functioning. Fire hydrants. Purpose of a fire hydrant. Well, pretty funny graphic there anyway. So near, but yet so far. Anyway, we know dogs and fire hydrants. But the purpose of fire hydrants, not only to fight fires, but flush pipelines, provide water to construction equipment, provide water to water trucks. Hydrants should be placed at intersections so they can be used in all directions from the corner. And again, as an operator, you're not going to go ahead and design that. If you go on and become a civil engineer, or you go ahead and work with a plan check, or you're a fire captain that looks at plan check stuff to approve it, you're certainly going to be looking at those kind of things. Depending on what the situation is, a residential area is going to use smaller hydrants and have less capacities needed than an industrial section. So fire hydrants can range in all kinds of capacity, and they're color-coded. We also have two types of fire hydrants. We have dry barrel and wet barrel. The one on the left is a dry barrel, and what you've got is you've got a valve and a key up top that goes all the way down to the bottom, and that's where the valve is. You also have a drain hole. So what happens is when you shut this, there's weep holes, and this actually empties out for a dry barrel. So it's designed for freezing. These are also a lot safer as far as they're designed with breakaway bolts. Now, on a wet barrel, you've got live pressure all the way up, and each outlet has a separate valve and operating system. And what happens then if a car or a truck hits this is where you get your geysers. So in a wet barrel, the barrel is filled with water at all times. It has no main valve. Each nozzle has a valve. It cannot be used in freezing climates and large water losses if a hydrant is broken. I've lived in a lot of cold climates, and the hydraulic pressure of freezing water is just phenomenal. If there's water in here and freeze it, it could be 2 inches thick cast iron, and it'll go ahead and break it. Unbelievable pressures with the freezing and the hydraulics. Dry barrel hydrants, the main valve is under the ground. It's used primarily in freezing climates. There's no flow of water from a broken hydrant, and they're either all the way open or all the way closed. Hydrant painting. Here's the color coding that I'm talking about. It should be visible day and night, and consider color coding hydrants or caps. Okay, and again, light blue, 1,500 gallons per minute. That's a lot of water. Green, you've got 1,000 to 14.99. Orange, 500 to 9.99. And Class C is less than 500. Now, a lot of residential and gallons per minute, GPM, a lot of residential areas are based on 175 gallons per minute and up. So again, the fire department, when a system is being designed, is very involved as far as the capacities of the system because of catastrophic events. Also the pressures and the flows. Okay, so here's a dry barrel, and what you can see is you've got your main here, and you've got a gate valve. Now, you can see this gate valve's like 4 feet down in the ground. So there will be actually a tube that comes up with a manhole cover up at the top, and that's operated with a big T-wrench. You've seen those guys probably with the big T-wrenches out there. But what you have also is breakaway bolts. So you got breakaway bolts right there. You got breakaway bolts down here. If a car hits this, ideally it's going to break off and it's not going to go ahead and have anything broken past the valve, which again gets into those geysers. In this picture up here, you've got the same thing going. You can also see they're putting tracer wire in. They put tracer wire in to go ahead and put some metallic in along a plastic pipeline or concrete pipeline so the metal detectors can pick it up when they're trying to find the pipes. Tracer wire. And again, you've got, you can see how pipes change in the type of materials and the different transitions. Valves are required in all water systems to start and stop the flows, regulate the pressures, throttle the flows, relieve pressures, and prevent backflow. This is a gate valve. Again, gate valves are by far the most common. Okay, many different types of valves, and here's just 12 of them, and there's a lot more than that. But you have ball valves, butterfly valves, needle valves, check valves, pressure relief valves, control valves, steam traps, strainers, diaphragm valves, plug valves, globe valves, gate valves. Okay, look at the size of those valves. Those things probably weigh about 800 pounds each. So again, when you get into some of these bigger mains that you're working on, obviously those things are set in, normally with either a front end loader and chained up and dropped into place. But again, this is where some of the biggest danger comes for workers as they're working on pipelines in an excavated ditch is, the dangers of, getting fingers caught in there, all that kind of thing. So, with that being said, there's distribution specialists, and there's also a lot of pipeline companies that's all they do is put pipelines in. Gas, oil, as well as water. Gate valves installed to isolate sections of the main to allow emergency repairs or replacement. Again, gate valves are going to be your best friend in a system. A vacuum pressure relief and pressure reducing valves are used to protect against negative or excessive pressures. Again, we're always concerned about the hydraulics of the water and sucking in contamination. Check valves are installed on the discharge side of a pump to prevent backflow when the pump is turned off. And again, there's many different, depending on the design of the system, but check valves can be all through a system. And what check valves allow is the water to move only one direction. A ball valve should be operated either fully opened or fully closed. Now you see the ball valve here, and you can actually see it's got a stainless steel ball with a hole right through it. And this is a very positive valve, and it sits on a nylon gasket, and it's a quarter open and a quarter closed. And so if the handle is parallel with the pipe, it's open. If it goes across the pipe, it's shut. 3 valves should be used at all crosses and 2 valves at all tees. Backflow prevention devices. Backflow devices are installed at the service connection downstream from the meter. We see these in the cities and the urban areas. These are backflows. This is a double check valve. It could be a pressure reducing principal valve like this one, but this is kind of a rare one. Most of them actually look like this. But it's a moderate amount of protection. A vacuum breaker is the least amount of protection. It's not recognized by primacies. I don't know if anybody's ever used a vacuum breaker. A lot of the new homes have them in the subdivisions on the hose bibs outside. And that way to prevent, go ahead and potentially some back seepage prevention. But the most efficient by far is an air gap. And an air gap, basically you have this atmospheric condition here, and you have the diameter of the pipe and at least 2 times the diameter in the drop. There's no way that water from down here is ever going to get sucked up through here. And this is what you see actually in a lot of commercial kitchens under the sinks. They're all air gaps because they are the maximum, most effective way to go ahead and make sure that backflow does not happen. Okay, so this is kind of, just a cutaway. And what we're looking at here is we have 2 gate valves, one on each side, and then we basically have our pressure reducing valve, our backflow valve. I'm sorry, not pressure reducing, our backflow valve. And they're spring loaded. And so it's basically the water's allowed through pressure, it's going this direction, to push this open, and it pushes the next chamber open. But if the water tries to go back, those springs slam that thing shut and won't let those waters go through. So, with that being said, these things are really expensive. And it's actually a separate certification that you can get, backflow certified. It's about a week-long class up in Sacramento. Costs about $1,500 to do. It's fairly math intensive. But if you get a backflow certification, a lot of people make a living doing nothing but backflow valves. Any commercial facility like a laundry or a Starbucks, any kind of restaurant, anything that's hooked up that's a commercial facility into a public water system, by law has to have a backflow valve. Those backflow valves have to be inspected every year. So you not only make money on the mandatory inspections, but the beauty is, depending on the water quality, they have to be rebuilt every 3 to roughly 8 or 9 years. And again, it's normally about a $95 per hour bench time to go ahead and rebuild those. So, I know one guy, all he does is one big hospital because they have over 300 backflow valves in the hospital. Cross connections and backflow prevention. A cross connection is where any connection to a public water supply and where a contaminant could enter. Contaminants enter the potable water system through backflow, back siphonage, and back pressure. So here's an example. We've got the kid in the pool, kid's doing the kid thing in the pool, little brown water going, whatever. But we also have a garden hose that's feeding into that pool, which a lot of people do. Now, there's no backflow on this system, but out in the system, then all of a sudden there's a broken pipe somewhere. What happens is the water goes to the point of least resistance, and so if there's a big breakout here, the water's going to get sucked right out of here and into that public water system, contaminating it. Here's an example of back pressure, and this is technically illegal, but you see this kind of thing happen all the time. This residence has a private well. Their private well is pumping out of there at 100 psi, pounds per square inch, going into the house. Now, they're also tied in to the community or a water utility with a supply coming in at 50 pounds per square inch. So what happens is the water from the well, and who knows how pure that aquifer is, goes through the house and actually goes back out into the main system, potentially contaminating it. This would be basically your meter curb stop, but again, a backflow valve would be put right there if that was the case. Again, backflow valves are very expensive. I ran a 2-inch main out to an ag barn that we had, and because it was tied into our well, I wanted to make sure I put a backflow on it. It cost me almost $1,000 for the 2-inch backflow valve. Water meters. The benefits of water meters include the capacity pumps can be determined. Customers basically are billed for water use. This has been the typical way, although this is changing because of conservation. Losses of water can be detected, and it prevents the waste of water and reduces consumption. There's certainly still a lot of systems that are not metered, although by law 2020 is the magic number in the year coming. Every system's going to have water meters on it. The primary function of a water meter is to measure and display the amount of water flowing through it. The amount of water produced needs to be determined, and a flow meter is a master meter, needs at least 10 diameters between it and any upstream obstruction. An upstream obstruction would be something, for example, like a valve. So we have a couple different types of water meters. We have large flow, which are velocity valves, which are Venturis, propellers, turbine, electronic, and insertion. We have small flows, which are displacement, which are nutating disc and pistons. And then we have variable flows, which actually is a combination of both. And the advantage of a variable flow meter is you're going to be able to go ahead and see your large volumes, but you're also going to have a much smaller dial that reads much smaller volumes that's going to allow you to help detect leaks. So here's again a couple cutaways. You have a propeller. That's pretty obvious. It's a mechanical thing with the water turning that propeller. You have Venturis. Venturis are basically where there's a reduction down in the size, and they're able to go ahead and directly meter off of that vacuum with a Venturi meter. You have turbine meters. This one's a fairly complex one with all the electronics on it and everything else. We're in a revolution right now that's electronic. It used to be, they started coming out with electronic meters probably about 15 years ago. And there were some problems with them. Originally, they were based off cell phone networks, and we certainly know how cell phone coverage can be spotty. Now they've gone ahead and evolved them to where it's a direct point and shoot to it, like a tablet or some kind of electronic component that the operator has when he's reading meters. And again, the new ones, they're pretty cool because all you do is basically get within about 10 feet of it, push a button, it beeps, it's automatically downloaded into your iPad. You go back to your office and download it. Automatically goes right into the billing. It's a very clean system. Small flow and positive displacement. Okay, residential normally goes to about 2 inch on the supply lines coming in from the meter. 2 inch is huge. A 2-inch line is going to be a really big property. But 5/8, anywhere from there on up. They're screened for protection. Now, a nutating disc is a positive displacement meter. You have this disc and it wobbles back and forth and it goes click, 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 click. And each time it clicks, it's a specific volume of water that's going through. And the same concept goes with the oscillating piston. Compound or combination. They may have separate registers for each meter, or output can be combined on a single register. So again, it might have 2 needles on it. But again, you can see the 2. You can also see the size of the pipe. When you get on the small one, they've reduced it down so they can read the smaller flows. And again, this gets into the electronics that I was just talking about. Standard compound meters consist of a turbine meter, positive displacement meter, and automatic valve arrangement. Wide variations of flow, and they're accurate for low and high flows. So installation, here's the old-fashioned type. Meter reader has to open the box, get down in there, flip the lid up on it. Hopefully it's not full of dirt and gophers and critters and everything else, and do a manual reading. These are still very common out there. With water meters, when they start to wear out, which they do, and again, depending on the water conditions, it could be 3 years, it could be 10 years, they don't speed up. They actually slow down to the customer's benefit. But some basic requirements, they must be leak tight. Obviously, you don't want leaks in your system. Accessible. Yeah, I've seen them in boxes that were below the ground where you couldn't change the meter out because there wasn't enough room. So again, common sense stuff. Protected against frost, damage, and tampering. Installed in a horizontal plane for optimum performance. Obviously, you want it in a nice, neat, plumbed-in situation. And you want to make sure it's easy to read directly or with a remote reading device. But you've got your water main off to the left here. You have the city shutoff right there. You have your water meter. And then you have a ball valve, which is on the customer side. The water meter is the magic line of whose responsibility that water system is. You get to the customer side of it, it's their bill if it has to be fixed. If it's on the city side, it's the city or the municipal's responsibility. So again, this is a ball valve like I was talking about earlier, a quarter turn. And you can see where it is right now. That's in the on position. If you rotate that a quarter turn so it's across the pipe, that's off. So, here's what we've got. We've got the water main out in the street, and coming off the water main, you have what's called a corporation stop, which is another valve. It's a valve at the supply line off the main trunk. This is called the service line that comes in. And then you have an angle stop, because oftentimes you have an angle stop on each side, so you can actually go ahead and shut the water off and change that meter. But it's obviously in a valve box. It's down below the ground. These are called meter sets. And again, this is the magic line. This side, it's all the city's responsibility or the water organization. This side, it's the customer's responsibility for any leaks in those lines. Surge tanks. Surge tanks are basically, there's air in the top of them, and water in the bottom. Oftentimes there's a gasket, a rubber gasket that goes in between, and it controls water hammer. And basically helps regulate the flow, and it prevents surges. It balances out that system. So again, it's kind of a shock absorber for those hydraulics. Anytime a pump starts or stops, fire hydrants. If somebody opens a fire hydrant really fast, it's the same thing. You can get water hammer going. And again, doing exercising in valves and hydrants, you always want to open them and close them slowly. And this is just kind of a graphic showing, you've got all kinds of things going on, and systems are going to become more and more complex because we've got purple pipe going with recycled water. We've got all kinds of different things, let alone all the utilities, cable, gas, phone, on and on and on and on. You've got your black water, you've got your gray water going. So again, it's going to become more and more complex and more interrelated with the water capacities in coming into that whole holistic thing that's happening of basically, hate to say it, toilet to tap, it's coming. Every drop of water will be accounted for. Okay, great. Hey, listen, I hope everybody enjoyed that. And feel free to give me a call and let me know if you have any questions. I'm definitely more than happy to get them answered for you. Take care. Bye-bye.